Welcome to CASIO Mathematics tutorial session. In the previous lesson, we covered real numbers, their types and the properties. In this lesson, we will cover the remaining properties of real numbers. In this section, we will go through additional properties such as additive identity. Any number added to 0 will give the same number. Example, a plus 0 equal a, 3 plus 0 equal 3, 112 plus 0 equal 112. So any number added to 0 will give us the same number. Some additional properties to investigate, which are properties of negatives. What are properties of negatives? Property 1, negative 1 multiplied by any number will result the opposite of that number. Example, negative 1 multiplied by a is equal to negative a. And also, negative 1 into negative a, I will get also a. So here, we are finding the opposite of a number. Whenever we are multiplying negative 1 by any number, we are finding the opposite of that number. For a numerical example, if you have negative 1 into 3, I will get negative 3. If you have negative 1 into negative 3, so I'm finding the opposite of negative 3, which is positive 3. Property 2, a negative number a multiplied by a number b, the result is the opposite of the product of a and b. Numerical example, negative 5 multiplied by positive 2 is the same as opposite of 5 times 2. Property 3, the product of a negative a and negative b equals to a times b. The product of two negative signs is positive. For example, negative 2 multiplied by negative 3 is positive 2 times 3, which is positive 6. Property number 4, negative of the sum of a and b is the opposite of a plus b. It is the similar case of property 1. Any number multiplied by negative 1, the answer is the opposite of that number. For instance, we have negative 1 multiplied by the sum of a and b. Now use distributive property. The answer will be negative a plus negative b, which is negative a minus b. As a numerical example, negative 1 multiplied by the sum of 2 and 3. Now we will apply the distributive property. You will get negative 2 minus 3, which is equal to negative 5. Also, on the other hand, if you need to simplify the parentheses at the beginning, I will get negative into 2 plus 3, which is negative into 5. Then the answer will be negative 5. Also, if we have negative into 3 minus 2, if I need to use the distributive property, the answer will be negative 3 plus 2, which is equal to negative 1. On the other hand, you can simplify the parentheses at the beginning. 3 minus 2, I will get 1. Then negative into 1, it will be equal to negative 1, as if I'm finding the opposite of 1. Now, let us do a practice on what we covered till now. Practice 1. Negative into negative 1 plus 3, is it equal to negative 1 minus 3? Let us use distributive property to check our answer. Now distribute the negative sign to each term. We will get positive 1 minus 3. Then the answer is wrong. Practice 2. Negative 2 plus 3, is it equal to negative into 2 minus 3? Take 1 minute to answer, and also you can put your answers in the comment. Yes, it is correct, since when we apply distributive property to the right side of the equality, we will get negative 2 plus 3, which is equivalent to the left side. Practice number 3, is 7 equal to negative 1 into negative 7? Yes, it is true, since negative of a number gives the opposite of that number, as mentioned in property 1. Practice 4. Negative 4 multiplied by negative 3, is it equal to negative 1 multiplied by the product of 4 and 3? No, it is wrong, since multiplication of two negative signs will result a positive sign. In this section, we will cover more properties. We have multiplication identity. What do we mean by multiplication identity? Any number multiplied by 1 remains the same. Example, 1 times 2 is 2. 1 times negative 4 is negative 4. Another property, which is multiplicative inverse of A, is 1 over A. Example, what's the inverse of 3? It is 1 over 3. So the multiplicative inverse of a number, it is 1 over the number itself. Additional information for fractions. Here we will deal with the operations in fractions. We will learn more about what operations we can do in fractions and how can we simplify fractions, add, subtract, multiply, or divide. Property 1. When multiplying fractions by each other, we multiply numerator by numerator and denominator by denominator. For example, we have A over B multiplied by C over D. The answer will be AC over BD. Property 2. When dividing two fractions by each other, the first step, we invert the divisor and multiply the two fractions. For example, A over B divided by C over D. First step, invert the divisor, it will be D over C. The division becomes multiplication. So the result will be A over B multiplied by D over C. So now we do the same steps as we did in property 1. Multiply numerator by numerator and denominator by denominator. So we'll get AD over BC. Property number 3, if we are adding two fractions with same denominator, we just need to add the numerators. For example, here, A over B plus C over B, the denominator in both fractions is B. So we only add the numerators together. So we'll get A plus C over B. We never add the denominators. Property 4, if we are adding two fractions with different denominator, first we need to find the common denominator between B and D. In this example, A over B plus C over D is the denominator of the first fraction. D is the denominator of the second fraction. Since both denominators are not the same, are not equal, we need to find the common denominator. The easiest way is to multiply B and D by each other. Once we found the common denominator, now we find the new numerators by multiplying A by D and multiplying C by B. So we'll get AD over BD plus CB over BD, which is equal AD plus CB over BD. Simplifying fractions. Whenever we are multiplying two fractions by each other, we need to simplify the numerator and the denominator. What do you mean by simplifying? Whenever we have a common factor in the numerator and denominator, we can simplify. In this example, we have AD over BC multiplied by BK over D. What are the common factors between the numerator and denominator? We have D, it is found in the numerator and denominator, and also B, it is found in numerator and denominator. So in this case, we can simplify B together, D together. So I will remain with AK over C. Make sure that the operation between the two fractions is multiplication. We cannot simplify fractions in the addition process, and we cannot simplify the fractions in the subtraction process. We only can simplify fractions an addition and subtraction at the end, at the last result that I can get after adding the numerators by each other or subtracting them. And also we can simplify the fractions if and only if they are multiplied by each other. If A over D equals C over B, then AB equal DC. We call this method by cross multiplication, that these two fractions are equivalent. If the left side equal to the right side and AB equal DC, then we say that these two fractions are equivalent. Then A over D equal C over B. Now let's have a practice. Choose the correct answer. Let's start by practice 1. 3 over 2 plus 2 over 3 equals 5 over 5. This is wrong. Since denominators are not equal, we cannot add the numerators directly. Practice 2. 3 multiplied by 2 multiplied by 5 over 2 multiplied by 7 equal 15 over 7. Here, we need to find the common factors between the numerator and the denominator. Then we check if the two sides are equivalent or not. The common factors here is 2, is only 2. 2 is found in the numerator and 2 is found in the denominator, so we can simplify it. So here if you multiply 3 by 5 you will get 15, and 7 by 1 it will be 7, so the answer is 15 over 7, so the answer is true. Practice number 3, we have 21 over 6 divided by 7 over 2 is equal to 3 over 3. First step, we need to simplify the left side. 21 over 6 divided by 7 over 2. In order to do so, the first step, as we mentioned, if we have division between two fractions, we need to change division into multiplication and invert the divisor. So I'll get 21 over 6 multiplied by 2 over 7. So the answer will be 21 multiplied by 2 over 6 multiplied by 7. So the answer will be 42 over 42, which is equal to 1. Practice number 4. 9 over 7, is it equal to 18 over 21? Then we need to check, is 7 times 18 equal to 21 times 9? So both answers, the left side and the right side, will give us the same answer, and these two fractions are equivalent. What is number line? A number line, it is a line that includes all numbers in it, the natural, the integers, and rationals. It contains the positive, negative numbers, fractions, and decimals. So in order to locate a point on a number line, we need to check on which side it belongs, to the left side of 0 or to the right side of 0. Is it rational or integer or natural? For example, locate the given points on the number line. A equal 3, B equal negative 4, C equal 1.5, D equal 9 over 4. For the first point, A equal 3, we locate point 3 labeled as A. Now B is negative 4, we label negative 4 as B. C is 1.5, we locate 1.5 on the number line. 9 over 4, we will change the fraction into decimal. We'll divide it by our calculator, CASIO FX 9 and 1 EX. So here it will be 9 over 4, it will be 2.25. We locate it on the number line. So in general, a number line, it contains all the numbers, rational, integers, and natural, even whole numbers. Intervals. What are intervals? Certain sets of real numbers called intervals occur frequently in calculus and corresponds geometrically to line segments. Intervals between 2 points A and B include all numbers between the two numbers A and B. We have two types of intervals: open interval and closed interval. What is an open interval? If A less than B and the interval is denoted by AB, parenthesis AB, then open interval parentheses a comma b include all numbers between a and b. But we should note that a and b are not included. Why? Because it is parentheses a comma b. So a and b are not included. In a set builder notation, we can say that the open interval AB is equal to any number which is x, such that x, which is that number, belong to an interval between a and b, such that a and b are not included. Now, if we need to locate it on a number line, we draw a circle on the boundaries, which is 3 and 6 in the example, like the open interval here is parenthesis 3 comma 6. So 3 and 6 are not included in the interval, so we place a hollow circle or an empty circle on 3 and 6 and we connect them with a line. So our interval on the number line will be from 3 to 6, but 3 and 6 are not included. Closed interval, if a less than b and the interval is denoted by brackets a comma b, then closed interval brackets a comma b includes all number between a and b and the endpoints. Note, a and b are included. In this case, the closed interval will include the boundaries a and b. In a set builder notation, the closed interval brackets a comma b is x, which is any number between a and b, such that a and b are included. For example, closed interval 3, 6, if I need to locate it on a number line, if I need to locate my answer on the number line, first we locate the boundaries, which are 3 and 6. We draw a full circle on 3 and 6, which are the boundaries, and then we connect them by a line. So this is my closed interval. An empty circle means an open interval. A full circle means closed interval. Let's have some practice. For the first question, the graph of interval -2, 5 is. The first thing we ask ourselves, is this open interval or closed interval? Since we have parentheses on both sides, it is an open interval. It is open from -2 and open from 5, which means that -2 and 5 are not included in our interval. And if it is not included in our interval, we will draw an empty circle on both boundaries, which represents the first number line. Second question, the set builder of interval 7, 9 is. For the first glance, we see that we have a parenthesis beside 7 and a bracket beside 9. Parenthesis, it means an open interval, which is 7, which means 7 does not belong to the interval. But if we look at 9, we have a bracket. That means that 9 is included in the interval. So which of the choices is correct? Choice number 2 is the correct answer. Why? Because it represents an interval where 7 is not included and 9 is included. Absolute value and distance. What do you mean by absolute value? An absolute value of a number, it means it is a distance, it is the distance away from 0. How much that number is away from 0. The answer of absolute value is always positive. Why always positive? Because the distance is always measured in a positive number. For example, if I need to find the length of a table, I cannot say that the length of the table is -3 meters. I will say it is 3 meters. Always the distance and measurement are in positive sign. So in the first example, we have absolute value of -3 is 3. Why absolute value of -3 is 3? If you place -3 on the number line and you calculate the distance between 0 and -3, I will get 3. So -3 is away 3 steps from 0. So the distance is 3. Also the same thing for absolute value of 3. I locate 3, then I calculate the distance away from 0, so I will find it 3 steps away from 0, so absolute value of 3 is 3. Now if we have absolute value of 3 minus 9, first let's see what is 3 minus 9. 3 minus 9, it is negative 6. Now place negative 6 on the number line, count the steps between 0 and negative 6, I will get 6 steps. So the answer is 6, positive 6. Using CASIO FX991EX, checks the answer of each absolute value. Press Shift, left parenthesis, negative 3, then press equal sign. To check the answer of the second absolute value of 3, press Shift, left parenthesis, 3, then press equal. To check the answer of the last example, absolute value of 3 minus 9, press Shift, left parenthesis, 3 minus 9, then press equal sign. Thank you for watching. Join us at our Teachers Forum and Education Resources through www.casiocalculators-mea.com, and don't forget to like, share, and subscribe.